borohydration. Okay, borohydration using diborane. Okay, so what are we going to use? We are going to use diborane. What is diborane? Diborane is B2H6. And what is B2H6? B2H6 is nothing but the compound dimer of BH3 and BH3. So BH3 and BH3 together dimerize to form B2H6. Now for many years, B2H6 had been a mystery. Okay, why was B2H6 a mystery? Because scientists were not able to understand that if a boron trihydride or BH3, if it is having 3 electrons in its outermost shell, so it has already spent its 1, 2, and 3 electrons. Now, from where does it have the fourth electron to combine with another BH3? Okay, this is another BH3, and that is also having 1, 2, and 3 electrons. So it's sharing 1 electron with hydrogen, and it is having 3 electrons in the outermost shell. Who? Boron is having 3 electrons in the outermost shell, so it does not have a fourth electron to combine, and therefore this was troubling the scientists, that how these two BH3 can dimerize. So later on, when during the discovery of electron microscope, it was found that these electrons are not stagnant or stationary, rather they are able to jump, because this boron is also electron deficient, this boron is also electron deficient, so they are able to jump in the form of a banana, right? It looks like a banana, that's why this is referred to as banana bond. So these electrons jump over here and form a temporary bond over here, and they again swing back. So same goes with these two electrons are also swinging to and fro. When they are swinging to and fro in the electron microscope, it was looking like the shape of a banana, hence this is called as a banana bond, and that's how BH3 and BH3 are able to dimerize with each other, forming B2H6. Okay, forming B2H6. So same B2H6 we are going to use with propene in the borohydration, right? We are going to use with propene to prepare an alcohol. So let us see how we can prepare an alcohol using propene and B2H6. So B2H6, so what are we going to do is we are going to take 3 propene molecules over here. Okay, or rather we'll have to take 6 propene molecules over here. So 6 propene molecules, and to the central carbon of this propene molecule, we are going to attach all the 6 hydrogens. So 6 propene molecules के 6 central carbons पे 6 hydrogens यहाँ पर attach हो जाएंगे. And when you do that, what are you going to get is, have a look, what are you doing? CH3 as it is, copy paste, then CH you are adding 1 hydrogen from here, over here. From where are you adding? From this BH6 you are adding 1 hydrogen over here. So it becomes, from CH it becomes CH2, double bond converts into a single bond, CH2. Same thing is going to happen with the other 5 propene molecules, right? We have taken a total of 6 propene molecules. So I'm showing it to you in this way. Have a look. So now this valency of this carbon is satisfied because double bond is broken, 1 hydrogen is added. But if you see that after breaking the double bond, these carbons are not satisfied. So they are connected to boron. Boron having a valency of 3, as you've seen in the banana bonding. Boron is having a valency of 3. So this forms tripropyl borane. What is this forming? Tripropyl borane. Name of this compound is tripropyl borane, and this entire compound is multiplied by 2. Why is it multiplied by 2? Because remember that you are having 6 propene molecules, so 2 threes are 6 propyl molecules will come over here. Boron, 2 ones are 2 boron molecules, and 6 hydrogens have been added to the central carbon. So this is how it forms tripropyl borane. But wait a minute, we haven't yet prepared an alcohol using this. So using your tripropyl borane, this time we don't require both. In step 2 we'll take only one of the above tripropyl borane. Okay, tripropyl borane molecules. And when we do that, after taking the tripropyl borane molecules, what are we going to do is we are going to take this tripropyl borane and react it with hydrogen peroxide. Now what is hydrogen peroxide? H2O2. If you want, you can write hydrogen peroxide as, instead of writing it as H2O2, we can also write it as HOOH. Okay, HOOH. So this is hydrogen peroxide. Okay, we have taken 3 moles or 3 molecules of hydrogen peroxide, and the bonds are going to break from the center. Okay, when the bonds break from the center, we are having 3 OH over here, 3 OH over here. We are having a total of 6 OH molecules. So these 6 OH molecules are radicals. They will combine with boron. So boron will combine with 3 OH, giving you H3BO3. You can call this as H3BO3. H3BO3 or BOH thrice is nothing but boric acid. What it is? Boric acid. Okay, and the remaining 3 OH you give it to the propyl, 3 propyl molecules, so you will get 3 times propyl, that is CH3 CH2 CH2 connected to OH. So 3 OH molecules will get attached to 3 propyl molecules and giving you what? Propan 1 all. Okay, giving you propan 1 all. Okay, so this is ultimately preparation of alcohol using what? Diborane, using diborane. Reaction of alkene converting into an alcohol. Previously, when we were using alkene to convert it into an alcohol, we used diborane or borohydration. Now we can convert an alkene also by hydration, simple hydration, water molecules H plus and OH minus in the presence of dilute H2SO4. So when you do this very simple reaction, what's going to happen is H plus will get attached over here, OH minus will get attached over here, and what are we going to get is simply ethanol molecule. Okay, CH3 CH2OH, CH3 CH2OH, that is nothing but ethanol molecule. Okay, now apart from this, let us also see, this is hydration of alkenes. You can also do it if you have taken symmetrical alkenes, no problem in hydration. If you're taking asymmetrical alkenes, just like haloalkanes, you will have to use Markovnikov's rule. The negative part gets attached to the carbon having the least number of hydrogens. Okay, who's the negative part? OH minus is the negative part in presence of dilute H2SO4. The negative part will get attached to the carbon having least number of hydrogens. Positive part will get attached to carbon having more number of hydrogens, and that's how you get propan 2 all. Okay, as your major product. Okay, propan 2 all as your major product.